Hi everybody, it's Tony E with Show IP Interface Brief, and I'm back with another LinkedIn challenge solution. There was another challenge posted to LinkedIn, and this one looked like it was a lot of fun. It's called the Z Lab. Okay, so here's the topology. As you can see, what we're trying to accomplish here is we're trying to get from loopback 1 over to loopback 2, but we want to take this Z pattern path. And what we're going to do is we're going to come over RIP, OSPF, EIGRP, and out to our loopback. So how do we actually do this? The challenge here is redistributing the routes in here in R2 and still forcing the traffic to go back out and back into R1. So to implement this, we're going to use VRF Lite. So what is VRF Lite going to do? Well, here's the traffic pattern we want to take. So what we're going to do is I'm going to use a different color, blue. I'm going to put these interfaces in a VRF, and I'm going to put these interfaces in a VRF. And so what that means is this interface and this interface will be in the global routing table, and this interface and this interface will be in the global routing table. Okay, I'm going to go ahead and post the configs online on my blog, but I just kind of wanted to go over and show how I did this and sort of walk through it. Okay, as usual, here's my Eve topology. Here's our loopback, and we're going to go ahead and take the path over gig 00, do a hairpin turn onto gig 01, out to gig 02, and then out to our loopback. This is a little different than what is in the actual topology. In the actual topology, he used sub-interfaces. And you can use almost the exact same configuration using sub-interfaces, but it doesn't look good here. It just shows as one router with a single line, so you don't get to actually visualize the path going back and forth. So that's why I used the 3 separate interfaces. But the same configuration could be applied to sub-interfaces as well. All right, to take a look at the configuration, I have console to R1. So if I do show IP interface brief, I have our 3 interfaces and our loopback. The interfaces are all configured on this router. They're going to be 10.1.11.1. This is our router number. This one is 11, this one is 22, this one is 33. So it's going to be 22.1 and 33.1. Over on this router, it's going to be 10.1.11.2 and 22.2 and 33.2 for all of the 3 interfaces. Here we have our show IP interface brief over on router 2. And we have our interfaces here. So if we want to go ahead and see which interfaces belong to a VRF, first we can do show VRF. And we see we have a VRF. I named the VRF EIGRP because that is the protocol it's going to be supporting. And over on router 1, show VRF OSPF to EIGRP because we're taking in an interface that was OSPF and it's going out an interface that's EIGRP. And here's our interfaces that are assigned to it. You don't see the interfaces that belong to the global routing table when you're looking at this show VRF output because they belong to the global routing table, not a VRF, not a virtual routing and forwarding instance. Okay, so let's go ahead and show some routing tables. If I just do show IP route, I'm actually going to be looking at the global routing table. In the global routing table, I have my loopback address, which is going to be my source, as well as a route to the classful address 2.0.0.0, which is from our loopback on the other router. So traffic is going to be leaving router 1, source from loopback 1, which is 1.1.1.1, and is going to go across to router 2 in the global routing table. That is going to be a RIP learned route. So let's go over to router 2 and show our global routing table and make sure we're learning our 1. Again, it's a classful entry, and we're learning it via RIP. from our router 1. You can see upstream we are learning our 2.2.2.2 back from router 1. Okay. Traffic is coming in router 2 on the 10.1.1.11.2 interface and is exiting and going back to router 1 at the 10.1.1.2.1. Excuse me, on the 10.1.1.22.1. When that packet arrives on router 1, it's going to come in on a VRF. Here's our interface and show VRF, and you can see we have gig 1 and gig 2. So it's going to come in gig 1, hairpin turn, come out gig 2. We want to see that routing table. We grab this name, show IP route VRF, and you can see my classful entry for the 1.1.1.1. I'm learning my destination via EIGRP, as indicated by the capital D on the left side. Okay, and then all the way over on router 2, show IP, excuse me, let's check our VRF name, show IP VRF, show IP route VRF EIGRP. I named it for the protocol we're going to be using. And here's our destination. You can see it's directly connected here. So we're really just making that Z shape all the way through to do a ping to 2.2.2.2, source from 1.1.1.1. It's looking good, and a trace route to 2.2.2, source from 1.1.1. I'm going to go ahead and throw Miracle on the back. As you can see, it's going across the 10.1.11. network, the 10.1.22 network, and the 10.1.33 network. So it's going 3 hops to its destination, traversing each link each time. This was a really fun lab. I had a lot of fun working through it. This was not my original approach. My original approach was slightly different. As you can see in this video, I have these 2 interfaces in the global routing table and these 2 in a VRF. I have these 2 interfaces in the global routing table and these 2 in a VRF. I originally designed this lab where all of the groups were in their own VRF, and I was having some trouble redistributing from OSPF over into RIP for this connection here. So my solution to that was to go ahead and throw them into a global routing table, and that seemed to solve the problem right away. So our packets now are traversing like this. And that's it. It was a lot of fun. Thank you very much. Please keep the good ideas coming and keep labbing.